highest of the levels we can go right now. All right, this is where my expectations are everyone's at this level. All right, so let's talk about this proof. Where do I go from here? We had to prove triangle KRM congruent to triangle PRO. I always got to check, is my darn mic on? Yeah, it is. Everyone, you can hear me. And in the givens, I had provided you guys that KR was congruent to RP. So right away, right here, take a look at what I'm doing. I gave you guys a pair of sides. Okay? I gave you guys a pair of sides. So you are on the hook for another pair of angle, sides, whatever. Two more pair. So let's go to the first given. Knowing 3 congruent to 6. How did that help you get another pair of angles in those triangles? Because you can't say 3 and 6, that gives me a pair of angles, because they're not in the triangles you need. So how did you use 3 and 6 to get to 4 and 5? I purposely labeled those angles 4 and 5 for you guys to find them. So how does knowing 3 and 6 are equal get to 4 and 5? Anybody want to open up and just throw some knowledge on myself and your classmates right now?
So what you do is you say that 6 is supplementary to angle 5 and 3 is supplementary to angle 4.
I'm listening. I'll write everything down at the end.
Then what you say is angle 4 is congruent to angle 5 because supplements to congruent angles are congruent.
Great job, Christo, correct?
Yes.
Okay, my screen is a little frozen right now, so I couldn't tell who was talking. Yes, guys, you had to say some stuff about supplementary angles that we did in Unit 2. Here's what you needed. And this didn't have to go first. It could have went later in the proof somewhere, but 3 and 4 are supplementary. Same thing with angle 5 and angle 6 are supplementary. Why were they supplementary? Don't make up a new reason, please. Every single reason I'm about to write down is something we have talked about in past units. This one, why are they supplementary? Because they're linear pairs. Linear pairs are supplementary. Okay? Everybody good? And if you didn't hear Christo's second part, because 4 and 5 are supplementary to congruent angles, they're congruent to each other. 4 and 5 are congruent. We had a theorem back in Unit 2 that said supplements of congruent angles are congruent. But you had to tell me those pairs were supplementary first. Okay? So 4 and 5, take a look. There is a pair of angles we could use. I'll mark them right now. Let's go purple. 4 congruent to 5. Everyone's all good on how I got 4 and 5, got you a pair of angles. All right, you still need one more pair of something though, right? One more pair of something. Look at the last given. KRO. Let me highlight that one. Everyone see this angle here? I guess I got to do 3 arc marks. I'm up to. KRO is congruent to PRM. 1, 2, 3. Everyone see those two angles. But here's the problem. Those angles are not angles in the two triangles I need to prove congruent. Some of it, part of the angles are, but not the full angle. I need angle KRM and I need angle PRO. So anybody new want to open up and tell me how you use those angles to get to the smaller angles in the triangles? How did you use those angles to get to the smaller angles in the triangle? Go ahead.
I used subtraction.
Darn right you did. Subtraction. That's how you got the angles inside the triangle. But as you guys know, you need 2 pairs of equal quantities to subtract, and I only have 1 pair right now, the orange pair. So Sarah, let me go back to you since you told me. What did you subtract from both of those angles to get the smaller angles?
MRO.
Yes, a reflexive angle you subtracted from both. Angle MRO congruent to itself. reflexive. And then in the next step, you told me what angles to subtract, which I'll write down right now, maybe. There we go. Come on, one job. There you go. I already wrote it down. Look at that. I just forgot to erase it from my previous class. All right, so I have the subtraction, the given angles minus angle MRO. That's what I just did there. The given angles minus angle MRO. And then nothing's changing. Nothing is changing. After subtraction, or if you use addition, substitution. All right, substitution. And that gave you a third pair of congruent parts. So everyone see how I got it. I use supplementary theorems to find one pair of angles. I use subtraction to find another pair of angles. So now I have two pairs of angles and a side. Two pairs of angles and a side. The only thing you guys got to figure out is, are these sides in between the congruent angles or not? Are those sides in between the congruent angles? And the answer is yes, they are. So that is the reason my method for the triangles being congruent will be angle side angle versus angle angle side. Okay? Questions from you guys there on that proof? Anything you want to throw at me? Again, like it or not, when I say this, this is where I'm expecting some of you guys to be now. And if anybody's thinking about asking this question, I'll answer it now. Yes, there are 3 proofs on tomorrow's quiz. One of them will be at this level. All right, there are 3 proofs on tomorrow's quiz. One of them will be at this level. All right, so just a heads up. I know some of you might have been thinking, asking that. Anything here, guys, before I move on to the bookwork? All right, I didn't think the bookwork was bad last night at all. Number one, there wasn't that many problems. Let me go to the algebra problems first, 14 and 15. I'm hoping you guys didn't make life complicated on yourselves here. All I needed you to do was 14 and 15, match up a pair of corresponding parts, whether they be sides or angles, solve the equation, and you're done. I'm hoping you didn't get freaked out by all the information they gave you. You did not need all the information in the diagrams. You did not need all the information in the diagrams. Okay, that was it. All good? And then how about this argument between Tyrone and Lorenzo? Pretty heated argument, it looks like. They were debating over triangle ADE, this top one, and triangle ACB, the bottom one. They're debating over those two, whether they're congruent or not. Tyrone just says, no, they're not. Discussion over. They're not congruent. Lorenzo's like, actually, because angle A is reflexive and it's in both of the triangles, I think we have enough to prove the triangle's congruent. Well, I guess Lorenzo doesn't know his 4 different ways to prove triangles congruent, does he? Because these are the only ones you're allowed. Side, 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 angle, angle, and angle, angle, side. There's no sides in those diagrams congruent, is there? Those 2 triangles they're arguing about, there are no pairs of sides congruent. That's it. So Tyrone wins that discussion. Those are not congruent. You do not see angle, angle, angle anywhere. And it's never going to come up. And it's never going to come up tomorrow on your quiz. So don't write it down. Angle, angle, angle is not and never will be a way to prove triangles congruent. All right? I am going to drive that point home today like there's no tomorrow. Right? Because I do not want to see angle, angle, angle written down somewhere on your test tomorrow. It's not a way. These are the only 4 you have to work with. That's it. That's the only 4 you have to work with. All good out there. And I know I get fired up, but still, I'm going to have somebody tomorrow write angle, angle, angle down as a way to prove triangles congruent, and I'm just going to, smoke's going to just start pouring out of everywhere. Any tests there? Test questions. See, I get too fired up. I get rattled. Anything. All right, check your proofs. Here you go. Check your proofs. To save time today, I'll tell you what you need in your proofs instead of you telling me what you put in there. Number 9, without a doubt, you needed to put that YV was congruent to VW. Definition of a midpoint. Do you have it in there? YV congruent to VW. Definition of a midpoint. No other line segments were congruent. Those were the only two by definition of a midpoint. From here, you had options. You could have said the vertical angles were equal. Vertical angles are congruent. You could have also said parallel lines imply alternate interior angles congruent. That would have been U and X being equal, or it would have been Y and W being equal. Okay? I can't tell you what method at the end to use unless I'm looking at your proof. You should have used angle, angle, side, or angle, side, angle, depending on what angles you used in the proof. Okay, I can't tell you what you should have used unless I look at your proof and see what angles you prove congruent. Okay, so you had to use the vertical and an alternate interior, or both alternate interiors. And depending on what you use, your final reason should have been angle, side, angle, or angle, angle, side. All good? All right, 10. Okay, take a look at 10. Everyone should have had those two sides in your givens. All right, first scenario, first type of proof. If you said M was congruent to R and S is congruent to Q because parallel lines imply alternate interior angles congruent. If you did that scenario, your final reason is angle, side, angle. If instead you use the vertical angles with a pair of alternate interiors, then your reason at the end should have been angle, angle, side. Okay? So again, if you use both pair of alternate interiors, you should be giving me angle, side, angle. If you use one vertical and one alternate interior, you should be giving me angle, angle, side. Questions on that? Any other things you want to throw at me for 10? And then if anybody tried it, this was my fault. Number 38 was assigned in the assignment sheet, but was not put in your packet. All right, at the end of you guys have seen it, at the end of every notes, I always put what the homework is, and I also have an assignment sheet. The assignment sheet had number 38 in it, but the packet didn't. I didn't want you to be responsible for that, so that was my fault. I should have taken that off the assignment sheet. So if anybody tried it and you're freaking out, don't worry about it. I'm not going to ask you to do something like that tomorrow. All right? Questions at all about the homework? Hopefully you thought it wasn't that bad. 2 minutes. Clean up, submit. Clean up, submit. And then we got to start talking about this bad boy we're taking tomorrow called the quiz. Back to business. Let's talk about tomorrow's quiz so you guys know exactly what the deal is. If you care, 13 questions, 39 points. And yes, this will be the final grade of the first quarter. Final test grade. All right, the quarter ends next Friday. And we're not going to have our unit test till after that. All right, so just a heads up. If you're disappointed in your grade, if you're very happy with your grading, you'd like to keep it there, this is our last test, last quiz or / test for the entire quarter. All right, since it ends next Friday. First 6 questions are going to be, let me just show you. First 6 questions, just like these notes were a couple days ago, where I'll mark up the diagram. If you're going to tell me they're congruent, give me the reason why. And not possible might be an option tomorrow. Okay, not possible might be an option. Remember, you guys know, you just saw how fired up I got about this. These are your only 4 options tomorrow if they're congruent. If it's not one of those 4, we're going to write not possible. So you should not be writing angle, angle, angle down, side, side angle. It's not a way. All right, everyone all right? First 6 questions tomorrow. All right, a couple other questions. One will be on interior angles of a triangle. I'm not talking about there's just 180 degrees and you're done. Here's what you can expect tomorrow. You can expect a diagram where the original triangle has multiple triangles inside. And what I want you to remember is I don't care how many triangles are in here. Each triangle contains 180 degrees, even if it's inside a larger one. Still contains 180 degrees. Still contains 180 degrees. As long as it's got three sides, it's 180 degrees. So that's what I'm talking about with interior angles of a triangle. Be ready for a crazy looking diagram, and you have to solve for X or maybe one of the angles inside. Number 4, the triangle exterior angle theorem. Woo, here you go. I'll just make myself a quick triangle with an exterior angle here. All right, hopefully you guys can see that. All right. I have an exterior angle at 1. Next to its angle 2, and then I have 3 and 4 over here. Anybody want to chime in? What do I mean by the exterior angle theorem here? What's
3 plus 4 equals 1.
Angle 1, the exterior angle, is equal to, we call them the sum of the 2 remote interior angles, which are the non-adjacent angles to it. Okay, an exterior angle is equal to the sum of the non-adjacent angles. All right. So be ready to set up an equation, solve it for X, and maybe even plug it in. Be disciplined, right? Be disciplined. Just because you find X doesn't mean you circle it and you move on. Might need a little more than that. Number 5, a review question from Unit 3. And I'll even narrow it down a little bit. The review question is going to be dealing with parallel lines and special angles formed from parallel lines. So what do you know about corresponding? What do you know about alternate interior, same side interior? It'll cover those topics. It will not cover slope, writing equations of lines. It will not cover that. It will cover special angles formed by parallel lines. And finally, number 6 up there, you got 3 proofs at the end of your quiz tomorrow, 5 points each. All 3 of them will have you prove 2 triangles congruent. Okay, all 3 will be proving triangles congruent. One of them, just like I mentioned before, will be at the difficulty level of the one we ended class with yesterday. All right, or I say difficulty level, maybe you didn't think it was difficult, so perfect. All right, but it's going to be at that same level. One of them out of the 3. All right, there you go, guys. Those are the topics for tomorrow. Anything I can answer for you?
I guess especially for the talking about the interior angles of the triangle and
Yes.
solving, will we have to set up any systems of equations
Nope.
to have 2 poles?
You will not, sir. Good question. You will not. Nope. You will not have to do that. All right. Good question. No factoring. I'll warn you guys if that stuff will be on there. All right. I'll give you forewarning. All right. No simplifying radicals. No distance formula. I will always let you guys know that. But no, none of that stuff tomorrow. Anybody else here? Questions before I move on? Okay. I do not, as you guys know, I do not give out practice problems for quizzes. I do that for the unit test. All right. So here's what, and I know some of you guys want to probably, if you had practice problems, you would try them. So here's what I'm going to start. I'm going to see how it goes now. If it doesn't go well, then I'm going to end it in this unit. I've started to dive into Delta Math. Some of you guys may have used it last year. Your algebra teachers might have used it before, Delta Math. And what I did on Delta Math was I created an assignment that's a review for your quiz. All right. So real quickly, if you're interested, this is not an assignment. I'm not even going to go into Delta Math and see if you did any or not. This is totally for your studying purposes. All right. If you have already used Delta Math before, you go there to the website, you sign in with your logon and password. Hopefully you remember it. And the only thing you have to do is type in my teacher code, which I have on the screen right now, 551912. If you've never been on Delta Math before, you go to the website, you use your school email to set up an account, and you type in my teacher code, 551912. And then you will see an assignment that I believe says Unit 4 quiz review, I think I called it. And In there, I have a bunch of questions that you can try, including proofs. If you want to try some triangle congruent proofs, those are on there as well. Okay? Again, not an assignment. I'm not even going to look to see who did it and who did not do it. It is just for your benefit. Okay? So I thought that would be helpful to some of you guys that want to study, because I don't have review problems for quizzes, only unit tests. Everybody okay with that? And obviously make sure when you get there you sign up for period 6. Any questions I can answer? And of course, I'll be after school today if you want to hop in and ask any questions there. That's fine too, as usual. All right, before I start today's notes, one announcement. Tonight's homework, there is an assignment tonight on your assignment sheet. Tonight's homework, let me bring it up here so you can see it. I'm actually doing you guys a pretty big solid here by doing this. Okay, tonight's homework out of the book. It's 4 problems. It's 4 proofs. These are not due until Monday. Not due until Monday, so that gives you tonight to prepare yourself for tomorrow's quiz. Okay, tonight's homework on the assignment sheet in your packet, 4 proofs, not due until Monday night. Okay, so you will not see anything on Classroom probably until this weekend. All right, that it's an assignment. All right, I'm giving you guys the opportunity to study for tonight's quiz if you want. But those 4 proofs are not due until Monday. Okay? Hopefully that helps you out preparing for tomorrow. Okay, let's get into today's topic. Let's get into today's topic, which is not part of the quiz tomorrow, so please do not think it's part of the quiz. It is not. I am going to tell you guys, this is how I'm going to start. Triangle WIS is congruent to triangle EUP. I did not provide a diagram. Didn't need a diagram. Okay? I do not need to draw a diagram. What I want to know is, based on what we've talked about so far this unit, can you guys come up with 6 true facts about those triangles? If you know they're congruent, what else do you know now? All right, 2 triangles are congruent. What else do you know now? So now I'm going to start calling on you guys, so be prepared. If the 2 triangles are congruent, give me 1 true fact about both of those triangles now that you know they're congruent. Let's roll. Boom. Quinn, can you give me 1 true fact?
Angle W is congruent to angle E.
Yes, it is. If the triangles are congruent, so are those 2 angles. Good start, Quinn. Now some of your classmates know where to go from here. Quinn, how about another one?
Angle P is congruent to angle S.
Got it. Angle S congruent to angle P. Why? Because the triangles are congruent. Boom. Oh, top of the list. Sarah, you got anything else for me?
Side WE is, oh wait, hold on. Side W is congruent to, oh my gosh, I'm messing up.
You're rattled. Come on.
I'm sorry. Angle I is congruent to angle U.
All right, you got it now. Good. It's all right. You saved yourself there. All right, what else? Let's keep going. Boom, Eric, you got something else that's true here.
Line WI is congruent to line EU.
Yes, it is, because the triangles are congruent. Yes. Come on, this train's going fast. Nate, got something else for me?
Line IS is congruent to line UP.
Got it. IS congruent to UP. I'll do the last one here. Line WS, or side WS, is congruent to side EP. All right. These were all, again, these were all called corresponding parts. And if the triangles are congruent, so are the corresponding parts. And that's what your proofs are going to be doing today. Is that I don't want the triangles anymore. In the proof statement, you're going to see prove to me a pair of corresponding angles or sides are congruent. Okay? That's what I need from you guys. Prove a pair of corresponding sides or angles are congruent. Oh boy, I hope we're not trying to finish the homework. Some of us here, hopefully we're not trying to do the homework. We're better than that. We're on the notes right now. Let's go to proof number 1. Go ahead, let's set it up. Ready? I have CA congruent to CB. I have a midpoint. You guys can handle that in a second. Part A. Okay, let's prove the triangles congruent. So this is good practice for tomorrow. All right, can you get the two triangles congruent? I should have marked it. I have a pair of sides down. You guys are, can you get me anything else? What else can you get me congruent on this diagram? Whew, here we go. Christo. Generator knows. What can you get me?
What I can get you is line AD is congruent to line DB.
Why?
Definition of midpoint.
Okay. That is a second pair of sides. Got it? We're good. What else is true? I should put DB, boom, boom. There you go. What else in this diagram is true? Ching, ching. Adam, what do you got for me? Number 11.
Angle CD, or line CD is congruent to line CD.
There you go. Hey, reminder, tomorrow you can mark a reflexive angle or you can mark vertical angles on your own. Anything else you do not mark on your own. Vertical angles you can mark and reflexive sides. Or angles maybe. Reflexive. And then that is another pair of sides. So it looks like we're good to go to finally say triangle ACD is congruent to triangle BCD. I just need to know which one of the 4 methods are we using here. Not bad question here at all. Zach, what method are we using here out of the 4?
Side, side, side.
There you go. Everyone's all right. That was part A. We could all hopefully do that. And don't expect one this easy tomorrow either. This is a little too easy. Now the new stuff for today, which is all right. The triangles are now congruent. Why are these angles ACD and BCD congruent? You got the triangles. So now why are those angles congruent? Well, look at your diagram. Aren't angles ACD and BCD, aren't they corresponding to each other? They match up, right? So just like we did in problem number 1 above, if the triangles are congruent, so are any corresponding angles or sides. ACD and BCD in this case. So what's going to be my reason I'm going to have you write down to show me that they're congruent? Ready? Corresponding parts, because that's what they are. Corresponding parts in congruent triangles. We just proved the triangle's congruent. Corresponding parts in congruent triangles are congruent. But you have to have the triangles congruent first. You have to have the triangles congruent. Now, I'll just tell you, That'll probably be the last time I write that reason down. Corresponding parts in congruent triangles are congruent because there is an abbreviation for it. And it's just not my abbreviation. This is a geometry abbreviation you'll see everywhere. The abbreviation. And again, you do not need to use this. If you want to write corresponding parts in congruent triangles are congruent, you go right ahead. Or you can do, ready? Corresponding parts in congruent triangles are congruent. Let that roll off your tongue, kids. CPCTC. CPCTC. A little tough, huh? Keep rolling off your tongue. Yell it in the house, why not? CPCTC. If you have any friends, probably not, but if you have any friends or siblings that have taken geometry before, let them know you just learned CPCTC today. They'll know. CPCTC. The only thing I'm going to warn you guys about, if you do use CPCTC, you better put it in the right order with the right letters. If all of a sudden you're like CPTAXYZ, nah, you're going to fly. Just make sure it's correct, please. All right, everyone good? And that is only after you prove triangles congruent. All right, CPCTC is not a way to prove triangles congruent. It is after you prove them congruent. Oh, you're still hungry. Oh, I didn't know you were still hungry. Here we go. Example 2. All right, part A, prove the triangle's congruent. We're almost there, guys, right? I gave you 2 pairs of angles. Anybody see anything else that's congruent in their diagram? Even if you're still jotting it down. Here we go. Ellie, do you see anything else congruent in the diagram?
Oh, line PS.
Yep, too easy for you, too easy. PS congruent to PS, reflexive. And okay, that was pretty quick, huh? Triangle PRS congruent to triangle SQP. Ooh, what's your reason going to be here? Be careful. Be careful. What's your reason going to be? Oh, down to 15. Provide. What's my reason? Why are those 2 triangles congruent?
Angle, side.
Good job. Angle, side. I don't know if some of you think the side's in between, but when you determine which one it's got to be, you have to physically, I always like to physically cover up one of the angles with my arm or my hand and then see, here are my 2 angles. Here's the reflexive side. That's clearly not in between those. So you have to look at one triangle only to determine which one it's going to be. And then, all right, if the triangles are congruent, look at part B. It's asking me why SQ's got to be equal to PR now. Well, because they're corresponding parts. And if the triangles are congruent, so are the corresponding parts, also known as CPCTC. Get a pair of corresponding parts congruent. Questions there from you guys? That wasn't bad at all. All right, this next one, maybe. Because I didn't give you anything congruent on this one. Nothing is congruent. That's up to you now to fill in everything. Because nothing is congruent I gave you. I just got parallel lines. Okay, before I ask you guys what's congruent to each other, look at the proof statement. I am no longer asking you to prove triangles congruent. I'm looking for side DC to be congruent to side BA. So if I am asking you for a pair of sides, maybe a pair of angles to be congruent, start getting in the habit of, oh, geez, those aren't congruent unless the triangles are. All right, so get in that habit. If you see two segments being proved congruent or two angles from here on out, probably have to prove the triangles congruent first. So I could say CPCTC. How do I get those two triangles congruent? Give me a pair of sides or angles. Liam, give me a pair of sides or angles you know are congruent.
AC is congruent to AC.
Okay, I got a reflexive side. AC congruent to itself. Done. I know I should be more consistent in doing this. That gives me a side. Somebody give me more parts that are congruent. What other parts are congruent in that diagram? Come on now, dig deep. Here we go. Owen, got anything for me?
Yeah. Here, let me look for a sec.
Sure.
DAC equals BCA.
DAC and yes, BCA. Good job. Let me mark those on the diagram in case anybody couldn't follow there. DAC congruent to BCA. What type of angles are they? Oh, and why'd you say they were congruent? Because they're
Alternate interior.
Good job, bud. Good job. Parallel lines apply. Alternate interior angles congruent. Great work. Great work. So that gives me a pair of angles. Anybody see anything else that should be congruent? Come on, you got it. You got it. Woo. Tim, see anything else that should be congruent?
DCA and BAC.
Good job. The other pair of alternate interior angles. Good job, Tim. Way to see it. DCA congruent to CAB. I'll just throw it in the same step. It's got the same reason. All right, finish it off. What method now would the triangles be congruent? What method? Is that side in between or not? How am I doing on time? All right, I got 45. Are those angle, side, or side, angle? Dun, dun, dun. Here we go. Zane, reflexive side in between or not? Angle, side, angle, or angle, side? Angle, side, angle. Good. That side is in between the two alternate interior angles. Angle, side, angle. And then we'll finish this off with CPCTC. Again, just make sure, how am I doing here? Perfect. Just make sure when you write your triangle congruent statement, I've been preaching this all unit, angles and sides match up. So if I go DAC, I got to name the other triangle BCA. All right. If you want to try that delta math out, go right ahead. It might help. Whoa, I forgot to tell you guys, 12 o'clock, test starts at 12, opens up at 12. You guys have the same setup as last week, right? Doing it on your Chromebook, phone, laptop off to the side on the Google Meet. Same setup as last week. I'll see you tomorrow with that setup.
Thank you.
Woo!